Hi everyone. So today we're going to work on solving systems in three equations. In other words, three equations, three unknowns. So if you remember when you're solving and you had one unknown like x, you would just like 3x plus 12 equals 10. We'd solve it. And if we had an x and a y and you wanted to solve for x, you needed two equations. And you use elimination, substitution, or graphing. Well, now that we have three equations, three planes like we graphed yesterday, we're going to have to do three equations with three unknowns. If I have three unknowns, x, y, and z, I need three equations. And if we want to build on that, suppose we had four unknowns, we would need four equations. Okay? All right, so we're going to try and solve, and what we're going to do is solve three equations with three unknowns. So here's the picture. All right? When you're solving three equations, three unknowns, we're looking to see, just like we did for two equations, where they intersect, if they intersect at all. So when we had two equations, we were looking for a point. Okay? What ordered pair makes both equations true? Now, if we're doing three equations, remember we're doing x, y, and z, we're going to look for an ordered triple to make all three equations true. So this is one solution. This is what it would look like. Okay? And what happens is that just like in the other ones, you can have no solution, meaning that we're not finding all three planes intersect. They all three may be parallel. Two might be parallel but intersected by a third. They may intersect, but two planes intersect at a time, kind of creating a little triangle there. So remember, we're looking for an ordered triple where all three equations meet or all satisfies all three equations. So that's no solution. We can have one solution. You can also have infinitely many solutions. That's this guy right here, where they intersect, but it's kind of like a pages in a book where they all kind of like are parallel and your answer's like a line. Okay? All right, so we're going to solve that. So we're going to do a couple of problems here. Okay, so remember when we graphed these equations yesterday, they were all planes. And we're going to look and see if we can find an ordered triple where all three planes intersect. Now the problem is how do we do that? So the way we're going to do it is we're going to do elimination. You can do substitution, but it gets very, very ugly. So we're just going to do elimination here, and graphing, not the world's best method. We can't graph it by hand. Okay, we're not going to find that point. So here's what we're going to do. We're going to pick two equations. So that's what we're going to start. So pick two and get rid of a variable. So again, doesn't really matter which two, but you want to make it as easy as possible. So I'm going to pick the first one, and I'm going to pick the second one, and I'm going to get rid of z because one's positive, one's negative. So I'm going to pick those two. Okay. And I'm going to add them together, and the z's are going to cancel out. There they go. Add my equations. And I get an XY equation as a result. Well, that's not really helpful because I still got to figure out what x and y are. And I have an equation I haven't used yet. So what we're going to do is we're going to take the equation we haven't used yet, and one we did, and get rid of the same variable. Key is the same variable. So we're going to get rid of the same variable twice. So this is a minus z. I'm going to use the first equation to help me. So that first equation is going to get used twice. So there's the first equation. And then here's my last equation, or the third equation. I'm going to add those two equations together to get rid of the z's. So there they go. Now, in this particular problem, it's very fortunate, something that's a bonus here. If we look and we're adding the two equations together, the y's cancel out too. That does not always happen. Okay? So when we add these two equations together, we actually are going to be able to solve for x right away. And we get 6x equals 18. So we can figure out what x, which is 3. Okay? So that's great. Now we know what x is. Now remember, we're going to look for x, y, and z. And now I can take that guy there, the 3, and come over here to the xy equation that we did earlier, and I can put that 3 in for x. And the reason why we're going to want to do that is we're going to be able to solve for y. Okay, so now I have an answer for y, and I have an answer for x. So our only thing that we have to find yet is what is z. Okay, so I'm going to pick one of the 3. It doesn't matter. I don't care. I'm going to just pick the first one, put in x and y. And solve for z. Zero is a legit answer, guys, by the way. So there's my order triple. 3, 2, 0. Okay. All right. Why don't you pause the video and try the next one on your own? Okay. Oops. Sorry. I thought I had one. Hold that thought. We're going to do this one together. It's number 2 you're going to do on your own. My apologies. Let's try this one. Okay, so we're going to pick 2 equations. Okay, so I'm going to start with, I'm going to pick my 2 equations and I'm going to pick a variable. I'm going to start with the first 2, and I'm going to get rid of the y's. Okay, so I'm going to add those 2 equations together. I don't have to do anything because my y's already are opposite signs, same numbers in front. We may have to change that. So we get 2x plus 4z equals negative 4. Okay. All right, and so now I have to pick the equation I didn't use, and one we did, and get rid of the same variable. So I'm going to get rid of the y's again, and I'm going to use the second equation. So x plus y plus 3z equals negative 3. 2x minus y plus 2z equals 0. Okay, I'm going to add those 2 equations together. My y's are going to cancel out. I'm going to add, so I get 3x plus 5z equals negative 3. Now, unlike the previous example, we didn't have 2 things cancel out. So now I have an equation with 2x plus 4z and 3x and 5z. Notice they're both x, z's. So now I'm going to take those 2 equations and pick a variable and solve it, or get rid of it. Now here, we're going to do elimination, but notice nobody has opposite signs, and nobody has the same numbers in front, so we're going to have to create that. I'm going to choose to get rid of the x's, because if I multiply the top by 3 and the bottom by negative 2, I'm going to be able to get rid of the x's. Okay. All right, so now I'm going to add those 2 equations together. The x's are going to cancel out. I'm going to add, so that gives me 2z is equal to 2, z is equal to 1. Well, that worked out. Now I'm going to be able to come over and pick one of the first 2, one of the 2 I just used, to find x. So I'm going to put 1 in for z in the first equation. I'm going to solve for x, and I get negative 4. So now I have my z and I have my x. I need to find the y. So I'm going to come back up to one of the originals. I'm going to go to the first one. And I'm going to put my x and my z in, and I'm going to solve for y. So I got y equals -2. So our ordered triple is -4, -2, and 1. Okay, so now I want you to pause the video and try number 2. Sorry about that. Okay. Remember, pick a variable, use 2 of the equations, get rid of the variable, do the same, take the line you didn't use, and when you did, get rid of the same variable. All right, so this is very similar to the first example where 2 of the variables canceled out in the second equation. So we're able to get z, y, and x. Okay, let's try another one just to make sure. All right, now here's a hiccup because if we look, this third equation does not have a y. So that's going to actually make our lives a little bit easier because I already have one equation with a missing variable. I just have an equation with x and z. So if we take these first 2 equations and get rid of the y, we're going to be like one step ahead. So I'm going to multiply this first top equation by 3 to get rid of the y's. Okay. 3 y's are going to cancel. So I'm left with -7x minus 2z is equal to -8. So now I have an xz here and an xz here. So I just need to use those 2. So I have 3x plus 6z equals -24. -7x minus 2z is equal to -8. I'm going to get rid of the z's because all I have to do is multiply the second one by 3. Okay, so -21x minus 6z equals -24. I'm going to add those 2 equations together. 6 z's are going to go. So that's going to give me 18x, -18x equals -48. Is that right? Or did I do bad math? No, I copied it right? So 8, 2 times 3, -3. Oh, no, I did bad math. I forgot to multiply my 2 by 3, so that's going to give me 6. This is going to be -4. Bad math. So this is going to be -12. And that's going to give me -36. That's going to make more sense because then when I divide, I'm going to get 2. Okay, so I knew something was off. All right, so now that we have x, we're going to come back over and find z. I'm just going to use the top equation. So 6 plus 6z equals -24. 6z equals -30. Z is -5. Okay, so again, once we have an x, we have a z. Now I'm going to go find the y. I'm just going to use the top equation. Oops, forgot to put my y. Y is -5. Okay, so it's -4 minus 5 minus z equals 2. So it's -9 minus z equals 2. Z equals 11z equals negative 11. So my order triple is 2. I did that wrong. You can tell I'm tired. That is completely wrong. Okay, that's right. Plus y minus negative 5, because z is negative 5 equals 2. There we go. All right, so negative 4 plus y plus 5 is equal to 2. So y plus 1 is equal to 2. Subtract 1, y is 1. That makes more sense. All right, so 1 and then negative 5. There we go. All right, pause the video, try the next one on your own. It's going to take you some time, and you're going to have to work through it. All right. This one had all the steps. And there we go. Not easy, people, and we're going to have to work through it. I know you got this. I believe that you can do it. All right? So let me know if you have any questions. Please stay safe out there, and I'll talk to you again real soon.